Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now let's look at this S1 paper, which is Probability and Stats 1, paper 5, and this is of October-November 2025, variant 51. Let's walk through the solution. First question, it says the random variable x only takes the value x with this particular probability, where k is a constant, x takes the value such and such. Draw up a probability distribution table for x, giving the probabilities as numerical fractions. That's the first thing. Find expectation of x, and this one, what exactly is this? Let's have a look. First thing first, plug in the value of x over here. When we put -2, after squaring it becomes 4. So this is 4k. If I put +2, still it's 4k. If I put in 1, it's simply k. If I put in 3, 3 square is 9, that's 9k. Since it takes only these values, therefore the sum of probabilities should add up to 1. So therefore k comes out to be 1 over 18. And yes, they are asking us to write it as numerical fractions. So let me write this thing as 4 over 18. This is 1 over 18. This is 4 over 18. This is 9 over 18. And remember my instructions, do not reduce the fractions. Leave it as it is. It will make your life very, very easy. Second part, find expectation of x, that is taking these values of x and multiplying it with the corresponding probability. So basically, -2 into 4 plus 1 into 1 plus 2 into 4 plus 3 into 9, and then divide once by 18 because you have followed my instructions and you have not divided it. So this comes out to be 14 over 9. Now what exactly is this part? This is conditional probability. Let me write the official formula, that is probability A slash B. Probability of A occurring given B has already occurred. B is the condition. Probability A intersection B divided by probability of B. Now over here, which one is B? So B is this one, that is x is greater than 0. And which one is A? A is this one, probability x does not equal to 2, not equal to 2, given that this condition is fulfilled. Now let's first look at this blue one, probability x is greater than 0. Greater than 0 would be this and this and this. So this is 1 plus 4 plus 3 plus 9, that is 14 over 18. That is this answer, 14 over 18. Now out of this, there are three things. That is this one, this one, this one. But probability does not equal to 2. So we don't want this one. We only want this and this. That is 1 over 18 plus 9 over 18. That comes out to be 10 over 18. Got the idea? So this thing is the numerator. And this thing is the denominator. Simply divide. 18 and 18 will cancel out anyway. So technically it's 10 over 14, which is 5 over 7. Very simple. The next question. Now this first question, let me label it. This one was about DRV, discrete random variable, also known as probability distribution. Now what is this one about? It says a fair 6-sided dice with faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 6 is obtained. Understand the vocabulary. The game is all about the vocabulary. This is geometric probability distribution. Probability of success is probability of getting a 6 repeatedly until a 6 is obtained. That's how I knew it's geometric. The number of trials is not given, cannot be binomial. Now it says find the probability that the 6 is obtained for the first time on the 8th throw. 1 mark, very basic stuff. This is a mix of binomial and geometric, as I'll tell you. And this is for 3 marks. And this has come a lot in 2024. So 2024 past papers, do have a look. There are at least 2-3 questions related to this. So coming back to this. So now over here, the geometric probability distribution, probability of success is 1 over 6. The 8th one is the success. So the final one is the success. And then there are 7 failures. So probability of failure raised to power of 7. probability of success will appear only once. This is the answer given to 3 significant figures. If you're interested in the exact form, you can write the answer as it is. That is perfectly exact. Basically, what they have done is that 5 raised to power of 7, that is this thing. 6 raised to power of 8, that is this thing. And that's how this is written. Now look at this one. Find the probability a 6 is obtained for the 3rd time on the 7th row. So now the 7th row, this is T7 over here. That is success. And out of T1, T2, T3, T4, T5, and T6, there are success on 2 throws. So it could be this and this. It could be this and this. It could be this and this, and so on. So therefore, this one is binomial. This one is geometric. This will happen and this will happen. So that is multiplication. So this thing over here, that is 6C2, that is 15. Success raised to power of 4, failure raised to power of 2, my bad, success raised to power of 2, failure raised to power of 4. That is this thing, and then this also needs to be fulfilled. So that is the success on the 7th row. So now according to indices 1 6 power 1, 1 6 power 2, that becomes 1 6 power 3. This is 5 6 power 4. 6C2 has a value of 15. And now use a calculator, evaluate, or you can leave the answer in the exact form or the simplified form of the exact form. So all got all clear. So this one is about geometric and binomial. This one, as you know, this is a back-to-back stem plot, median, quartile, stem, the mean and standard deviation, things like that. So now there are 2 categories. There are 2 companies. This is brown, this is green. There is 27 employees of each. This is about the annual salaries in dollars. Now 6/32/7. So that is like 6/32/7. So 32/6 for browns means 32,600 for browns. So this is the red one, that is for the browns. This is 6 and 32. And then over here for the greens, 32/7, that means 32,700 for greens. Now it says find the median and interquartile range for the employees at brown. So 27 divided by 2 is 13.5. It's an odd value because there are 27 pieces of data. So there is a middle value. So that middle value is 14th. That you need to realize. So T14 is what comes in the middle. 13 values are below it. 13 values are above it. 13 values are smaller. 13 values are bigger. The median of those 13 values is lower quartile. The median of the bigger 13 values is upper quartile. So 13 divided by 2 is 6.5. Rounded up, that's the 7th value. And similarly, 7th value out of the bigger one. So I don't use any fancy formulas. That's 1/4, n plus 1, things like that. I personally believe in working like this. So now these numbers are for your guidance. 3 plus 7 is 10. So 11, 12, 13, 14, that is your median. 4/32, that's right over here. And 1, 2, 3, 4, 5, 6, 7, that is your lower quartile. 3/31, that means this much. Similarly, 1, 2, 3, 4, 5, 6, 7, that 5/33, that's your upper quartile. So we have the median, we have the upper quartile minus lower quartile, that's the interquartile range. So now the next one. Now it says the annual salary. I think that was the monthly salary. That was also annual salary of 27 employees. And this is the annual salary of an employee is brown, is denoted by X $1,000. So don't forget this thing, which is this factor of $1,000. And the annual salary of employees at greens is denoted by Y $1,000. It is given for the 27 employees. So now it's 27 at each. So over here, number of people at X is 27. Number of people at Y is also 27. And the data is given. So basically, it's combining sets of data. So combining sets of data. So now we know that sigma x is given, sigma x square is given, number is given, the same thing for y. Red is for brown, green is for, green color is for greens. So let the new variable be w, that's for the total. W bar, take, let me just adjust it. So now W bar, take this sigma X, take this sigma Y, add it up, divided by 27 plus 27, that is this much. This is the unrounded value, this is the rounded value, multiply by 1000 because the unit is in thousands of dollars. Similarly, sigma square, SD square for W, take this sigma Y square, take this sigma X square, add it up, look at the working, show all your working to gain full marks, divided by 54 minus this thing is right over here. And then we get this value, SD is 1.36 by taking the square root and multiply by 1000, that is 1360. So final answer, final answer. Now this question was slightly tricky, slightly out of the box. It says bag A contains 8 red and 3 blue marbles. So let me just put some color in it. That is 8 red marble and 3 blue marbles. And then over here 1 blue marble and 4 red marbles. So this is over here bag B and this one over here is bag A. So that is bag A, again bag A, and this middle one is bag B. Okay, now keep this in mind. Now it says a marble is chosen at random from bag A. So 8 plus 3 is 11. That's 8 over 11, 3 over 11 makes sense. Bag B contains 4 plus 1, that is 5. Now over here when we look, we see a 6 over here. Unsure whether this is 5, whether this is 6, we are not sure. Now here are the rules of the game. A marble is chosen at random from bag A. If the marble is red, it is discarded. So discarded for what? It says in the next line. If the marble chosen is blue, it is placed in bag B. So now if the marble chosen is blue, it is placed in bag B. Okay. Now what happens next? A marble is then chosen at random from bag B. So now that will come up later. Let me first focus over here. Now first think about it. How in the world this thing is happening, which is this 3 is becoming this 2, because originally there was 1 blue marble over here, right? So technically when we are choosing a blue, this 2 is technically 1 plus 1, the original one and the one from the transfer. That's what makes it 2. And this 4 over here, that is the original one, that is 4. The denominator makes sense. Why is the denominator 6? Because the denominator is 6 because of 5 plus 1, that is 6. There were originally 5 marbles, 4 plus 1 is 5, 1 from the transfer. So that transfer, this transfer will work only for which color? Only for blue. Transfer works for blue from bag A. That is the rule. So that is why this is 6, this is 6, this is 5 plus 1 because of that, and this numerator is unchanged. And we also know that if this is 2 over 6, this has to be 4 over 6, 1 minus that. Now when we are choosing red, nothing changes. So now the denominator over here is 5. The denominator over here is 5 because you're not adding anything. And this is simple. This is 4 red, 1 blue. This is 4 red, 1 blue. That is the first thing that you need to fulfill. Now we have to move to the next one. Now it says a marble is then chosen at random from bag B. So now we are choosing a marble from here. If the marble chosen is red, it is discarded. Now let me just write the colors, which I forgot. That is red, that is blue, that is red, that is blue. Over here, follow the same streak, red, blue, red, blue, red, blue, and red, blue. And now it says if the marble chosen is red, it is discarded. So this we are choosing from bag B. And if the marble chosen is blue, it is placed in bag A. So now bag A, originally there were 8 over 11 and 3 over 11. First of all, let me just write the denominator, that is 10, that is 10. Right now this is 10, this is 10, because the original number of marble was reduced. Now in which case will this 10 become 11? Let's have a look. With red, nothing is happening. So 10 remains as 10, 10 remains as 10. With red, nothing is happening. This 10 and this 10 remains the same. Now with blue, everything happens. So this 10 becomes 10 plus 1, this becomes 10 plus 1, this becomes 10 plus 1 because of the blue, and this becomes 10 plus 1. Got the idea? So now what will happen? So now bag A has which numbers? So if we are talking about red, original red was removed. So now in bag A, 7 reds are left. Got the idea? Now, originally, if this is 7, naturally this has to be 3. Don't overthink. Similarly, over here, if we are talking about this thing, if blue is taken out, so now this blue of 3 became a 2. So now this blue became a 2 and 1 was added because of the transfer. So that becomes 3. So now over here, 3 over 11, and this becomes 8 over 11. That is all good. Now over here, if we are again talking about a blue, and if blue is taken out, then the original number of blue was 3. So that thing was 3 and 1 because of the transfer. That is like this. And this red over here, 4 over 11. And this is 7 over 11. So that's how it is. So technically over here, this one red, that red becomes 7. This red becomes 7. This blue is 3. This blue is 3. Because of the blue transfer, 1 was added. And now let's talk about this one, the last missing piece of the puzzle. If blue is taken out, the red is still 8. So the red is still 8. So therefore, the 3 became a 2. So let's double check. This is 7 over 10. This is 3 over 10. My bad. This is 7 and this is 3, I think. Yes. This is 7 and this is 1 plus 3. This is 7. This is 1 plus 3. This is 8. This is 2. This is 8. This is 3. So all good, all clear. Let's double check. I have done it over here. This is 7, 3, 7, 4, 8, 2, 8, 3. 8, 2, 8, 3, 7, 4. All good. Now the next part, let's have a look over here. Find the probability. All 3 marbles chosen are of the same color. That was very easy. So that is free marks. That is red, red, red. So that is red and red and red. And the last one is blue, blue, blue. That is blue and blue and blue. You multiply it out, work in fractions, leave the answer as it is. Remember the famous saying, that is, fractions are supreme. Fractions are beautiful. And above all, fractions are exact. And that is my saying. So don't search for it on Google. So now let's focus on this one. On any given day, Cooper wears a blue jumper, green jumper, does not wear a jumper at all. Blue jumper 0.6, green jumper 0.3, and does not wear, that has to be 0.1. Find the probability in a week, 7 days, so that people don't confuse with like a holiday or something. Cooper wears a blue jumper at least 5 days. Use a suitable approximation. Find the probability in any 150-day period. Cooper does not wear a jumper on fewer than 22 days. So now basically, let me first write things over here. This is basic probability, not very basic, but basic. Then this is stem plot. And this is mean and variance. That is the kind of thing that there is. And this one is geometric plus binomial. That is the basic idea. So now coming back to this, I think that's the one. Yeah. So now over here, just have a good look. It says blue is this thing, and we are talking about blue jumper. So if we are talking about blue jumper, therefore the probability of success is blue. Probability of success, probability of success, probability of success, raised to power of 5, raised to power of 6, raised to power of 7, because we are talking about at least 5 days. That is 5, 6, 7. And you know the basic, 7C5, success raised to power of 5, 7C6, success raised to power of 6, 7C7, success raised to power of 7. The difference between 7 and 5 is the power of probability of failure. Now look at the working over here. Write it all out. At least 4 SF. 5 SF, 6 SF, good enough. Then add it up. And then simplify. So this is 1, 2, 3, 4. This is the fourth significant figure. 4199 becomes 420. That is the final answer. Now it says use a suitable approximation. Find the probability that in a 150-day period, Cooper does not wear a jumper. So does not wear a jumper, that is this probability of success, that is 0.1. So that is this success 0.1. So now this is N, this is P, this is Q. Evaluate everything, whether the examiner asks for justification or not. It's my habit to write down the justification. Justify the use of approximation. So now over here, this thing is there, which is, let me just change the color. NP 15, NQ 135, NP greater than 5, NQ greater than 5. So now NPQ is the variance. So NP, we know it's the mean. NPQ, that is the variance. If this condition is fulfilled, it goes down over here. That is NP, NPQ. Don't forget continuity correction. Let me draw a number line. Show everything to the examiner. Do not assume anything. Yes, the examiner is a learned person, but you have to show him everything. This is 22. This is 22.5. This is 21.5. Now draw two arrows pointing to the left. That's one of them. That is the other one. Now which one is the suitable one? Since 22 is not inclusive, that's the correct one. The orange one. So the orange one is the correct one. That is the continuity correction. And then you standardize 21.5 minus the mean divided by square root of variance, which is standard deviation, and you get this value. Now remember the Z value, that is the maximum 3 dp, that is the limitation. 1, 2, 3. Read off final answer, round it off to 3 SF. Maybe sometimes it's already rounded off. Otherwise, you have to round it off. Question number 6. Now, this is a normal distribution thing. Let's have a look. It says a factory produces chocolate bars. The weights are normally distributed with mean 155, standard deviation 6. A random sample of 350 of these bars are chosen. Now, as soon as they give you a number of chocolate bars, that means binomial is in the shadows. So first of all, this part, that is about normal. That is, X follows a normal distribution. Find the probability between 148 and 160. Standardize. One Z value is negative, the other one is positive. According to the numbering that I have given you, that is rule number 7. That is, read the table for the small value. First of all, discard the negative sign. So small or big doesn't make a difference. Read the table for one value. Read the table for the other value. That is the probability corresponding to this. The other one is the probability corresponding to this. Add both, subtract 1, and that is the final answer, which comes out to be 0.6759. Now, I have not rounded it off because they're not asking us the probability. They are asking us expected value. Now, this thing over here, that is binomial. So expectation, or you can simply say it in maths, it's a ratio. So this is percentage kind of thing. So 0.6759 of 350, that is the idea. Of means multiplication. You get this answer in decibels. Both are accepted. You either round it up, that is good. You either round it down or round it up. Both are accepted, good. Doesn't make a difference. But yes, give the answer as an integer. That is a must. That is necessary. You have to give the answer as this. Now the question continues. Again, normal distribution, the traditional question, which is about finding the value of mu and sigma based upon the information given. So now it says a second factory also produces chocolate bars. The weights are normally distributed. This is unknown mu. This is unknown sigma. 8% more than 114. 8% more than 114. 20% less than 99.5. 20% less than 99.5. right away change it because this is lesser than 50%. So 8% becomes 92%, inequality flips. 20% becomes 80%, inequality flips. Now we will standardize, we will get a z value, lesser sign, z value is positive. A z, greater sign, z value is negative. So first show the standardization, subtract mean, divide by sigma, subtract mean, divide by sigma. Now we will go to back solving thing. So remember, this is probability and read the z value. This is 80% probability, read the z value. This is p value. So this is like a question of back solving. Whenever probability is given and you have to find the z value, that is back solving. Now this is basic maths. You get two equations. You solve simultaneously. Of course, you should show the working. I have just given the final answer over here. I have guided you that how to work it out. So show all steps, every step that you are doing that is necessary. Now we are on the last thing, and that is about the famous chapter, the most fearsome, that is permutation combination. But I think it's a very straightforward chapter, straightforward working, which you have seen in the past. So now this word, seashells. So now there are two S, there are three E's, there are two L's, there is YCH. First thing, different arrangements. So 10 factorial divided by 2 factorial for the S. This 2 factorial is for the S. This 3 factorial is for the E. This 2 factorial is for the L's. So use a calculator. So this is S and this is E and this is L, and you get this answer. This answer is exact. Leave it as it is. Now this one we have seen again in the past. This is with a slight twist, nothing difficult. How many different arrangements are there of 10 letters of the word seashells, in which there are exactly 2 letters between the S's, and one of these 2 letters is a C. So diagram is a must. So this is for S, this is for S, and the C, which color is the C? The C is the purple color. So the C could either occupy this or this, any one of these 2. So now I have drawn lines. This is the first and the fourth, second and fifth. I'm moving it 1 unit ahead. Third, sixth, fourth, seventh, fifth, eighth, sixth, ninth, 7th, 10th. It has to stop at 10. So how many lines do you see over here? So what we see is that we have 7 lines. So that is how the diagram is needed. So there are 7 lines based upon this positioning. Now, S is fixed, that's one possibility. This S is fixed, that's one possibility. 7 lines, that is this thing. What is this 2 for? Either C is over here or C is over here. So that there are always 2 possibilities. I don't want to draw 14 lines. So that is why I multiplication by 2. That is the positioning of C. Now, how many spaces are left? So 1, 2, 3, 4, 5, 6, and 7. Any one of the 7 could occupy these spaces. That is 7 factorial. Why 3 factorial? Because 3 factorial is for the E's and 2 factorial for the L's. So this is for the E's, this is for the L's. And no division by S, because S is fixed. S is fixed, S is fixed. And that is the exact answer. There are different other ways that they have done it. I personally feel this one to be the easiest. That's the way I teach it. Now let's move on. How many different arrangements are there of 10 letters of the word in which there is a S at the beginning? So S is fixed. S at the end, that is fixed. And there are 3 E's are not all next to each other. So maybe 2 E's are together, 1 is not together. So again, there are more than one method. I have done it. This is fixed. This is fixed. This is without restriction. This is fixed. This is fixed. Now the E's are together. Now we don't care if the E's are not together. They are all separated. So that's a long way. This is the shortcut based upon subtraction. Without restriction, S is fixed. Without S is fixed and 3 E's are together. So 3 E's are together. Put them in a box. There is Y, C, H, L, L, S. Sorry, this S is fixed. So now 1, 2, 3, 4, 5, 6. That is 6 factorial. 2 factorial division is for the L's. What is happening inside the box? Technically nothing. 3 factorial over 3 factorial is 1. So this answer is 3360. This answer is 360. This answer comes out to be 3000. Again, exact. Now the last part, it seems difficult, but it's very easy because the keyword over here, which I have explained to you in many videos, is that it's about the wording. That is find the probability. They're not asking for the number of ways, they are asking for the probability. 5 letters are chosen. So now there are 3 E's, they are included. So that's 3C3. And in probability, when this thing happens, so now it doesn't make a difference whether they are identical or not. There are 7 of them, you have to choose 2. So technically 7C2, this answer is 21. Without any restriction, that is 10C5, that is 252. When we divide, we get this answer in the exact form, that is 1/12. So yes, we just finished this paper, which is October-November 2025, variant 51. And that's all done and dusted. Few more S1 papers coming up along with P3 papers. So get ready, gear up for your exam. Take care, everyone.